Question 8, Part B. Joe borrows $200,000 which is to be repaid in equal monthly installments. The interest rate is 7.2% per annum reducible, calculated monthly. It can be shown that the amount, AN dollars, owing after the nth repayment is given by the formula AN equals 200,000 times R to the power of N minus M times open bracket 1 plus R squared plus plus R to the power of N minus 1 close brackets, where R equals 1.006 and M dollars is the monthly repayment. Do not show this. Part 1. The minimum monthly repayment is the amount required to repay the loan in 300 installments. Find the minimum monthly repayment. Starting with the expression given, that is AN is equal to 200,000 times R to the power of N minus M times 1 plus R squared plus plus R to the power of N minus 1 in brackets. We recognise that what's in brackets is a geometric series. First term 1, common ratio R, and there are n terms in this series. So we can replace what's in the brackets here with the sum of a geometric series formula. So we can rewrite AN as 200,000 times R to the power of N minus M times 1 minus R to the power of N over 1 minus R in brackets. Now the question's asking us to find the value of M, which represents the minimum monthly repayment. Given A300 equals 0, what this means is that after 300 months, the loan is completely paid off. So we need to solve for M the equation 0 equals 200,000 times R to the power of 300 minus M times 1 minus R to the power of 300 over 1 minus R in brackets. And we know the value of R, it's given as 1.006. We'll substitute that for R later on. Rearranging this equation, to isolate this part of the expression here involving the M, we get M times 1 minus R to the power of 300 over 1 minus R in brackets equals 200,000 times R to the power of 300. We can isolate the M by dividing what's on the right hand side with the brackets on the left hand side. So M is equal to 200,000 times R to the power of 300 divided by 1 minus R to the power of 300 over 1 minus R in brackets. Now we can substitute 1.006 for R. So M is equal to 200,000 times 1.006 to the power of 300 divided by 1 minus 1.006 to the power of 300 over 1 minus 1.006 in brackets, and that evaluates to 1,439.1773 and so on. Therefore, the minimum monthly repayment is $1,439.18, correct to the nearest cent. Part 2. Joe decides to make repayments of $2,800 each month from the start of the loan. How many months will it take for Joe to repay the loan? Let the value of the monthly repayment M equal $2,800. The loan is fully repaid when the value of AN equals 0. In other words, we want to find the value of N such that the expression that represents AN is equal to 0. So we need to solve for N the equation 0 equals 200,000 times R to the power of N minus 2,800 times 1 minus R to the power of N over 1 minus R in brackets, where R is equal to 1.006. We can eliminate the denominator 1 minus R by multiplying all terms of the equation by 1 minus R. So the equation becomes 0 equals 1 minus R in brackets times 200,000 times R to the power of N minus 2,800 times 1 minus R to the power of N in brackets. Expanding the brackets here, we get 0 equals 1 minus R in brackets times 200,000 times R to the power of N minus 2,800 plus 2,800 times R to the power of N. Now the negative 2,800 on the right hand side can be moved over to the left hand side and it becomes positive 2,800, and we can factorise out R to the power of N from both of these terms. So the equation becomes 2,800 equals R to the power of N times open bracket 1 minus R in brackets times 200,000 plus 2,800 close brackets. At this point we can substitute 1.006 for R here and evaluate what's in the brackets here, and that evaluates to 1,600. So the equation simplifies to 2,800 equals r to the power of n times 1,600. We can isolate r to the power of n by dividing both sides of the equation by 1,600. So we get r to the power of n is equal to 7 over 4. Now 7 over 4 is 2,800 over 1,600 simplified. Now r is equal to 1.006. So we can substitute 1.006 for r here. So the equation becomes 1.006 to the power of n is equal to 7 over 4. To isolate the n, we need to take the logarithm of both sides. I'm going to use log base 10. We could use log base e or natural logarithm, ln. So taking the log base 10 of both sides of the equation, we get log base 10 of 1.006 to the power of n is equal to log base 10 of 7 over 4. Now the power moves out to the front, applying one of the logarithm laws. We get n times log base 10 of 1.006 is equal to log base 10 of 7 over 4. Dividing both sides of the equation by log base 10 of 1.006 to isolate the n, we get n is equal to log base 10 of 7 over 4 divided by log base 10 of 1.006, and that evaluates to 93.54. Interpreting this result, the loan will be fully repaid after 94 months. So we have 93 complete payments of $2,800 per month plus a partial payment.